Hello everyone, welcome back to the engineers. This is the day 4 of our programming series. Today we are diving into the really interesting question. How does the computer actually understand our code? We write the code of anything in the Java, Python or C using English word, but the computer doesn't understand English. It only understands zeros and ones. So how does it all work? To explain this, I use a funny analogy, the chef and a recipe example. Let's start. Now think about this when we type system.out.println in bracket hello world. In Java, what actually happens? We can read it, understand it, but for the computer, this text means nothing. The CPU, which is central processing unit, which is the brain of the computer, only understand the binary instruction, which are zeros and ones. So the real question is, how does our English like Java code turns into zeros and one that the CPU execute? Let's understand this using our shape analogy. Now, as we see on the screen, imagine you are a chef working in a kitchen. You, the shape, that is equal to the programmer. Now the recipe is the code which you write. The translator, that is the compiler or the interpreter who explain the recipe step by step. Now what is the compiler and interpreter? We will discuss rather in this video only. And finally, your assistant shape, the computer CPU, who actually does the cooking. So here how it works. The shape write the recipe, the translator make it understandable, and the assistant execute it perfectly. This is perfectly how computers understand the programming language. Now let's understand this in various way. Now let's map this analogy into the Java. We first write our Java code in the .java file. Means .java is our extension for Java language. That's like a shape writing a recipe in English. Now the Java compiler called Javac, Javac, which translate into the Bytecode. Now what is the work of Javac? It only translates the main Java code into the Bytecode, which gives us a .class file. Think of this as the translator, turning the recipe into the precise instruction. The JVM, Java Virtual Machine, takes this bit code and convert it into the machine code, the actual zeros and ones. Finally, the CPU execute those machine instructions and we see the output on the screen. So whole journey is .java file to compiler to .class file, then JVM to machine code to CPU, and CPU to output, as we have seen in the screen. Now let's move forward, break down all the words which we use there. Now why not write in machine code? You might wonder, if computer only understands zeros and ones, why don't we just write in binary directly? Well, imagine writing an entire program with thousands of lines all in zeros and ones. Impossible for humans, as we see on the screen, ones and zeros, which is very complicated to understand, which is very complicated to imagine and also execute at the time of execution. That's why we have high level language like Java, Python or C. These are much easier for a human to read and write, and the compiler plus JVM acts as a translator, making sure the computer can still understand everything. Java is special here because of its once write once. What I say, Java is special here because of its write once, run anywhere. Means it is the speciality of Java, write once, run anywhere. And the philosophy is that Bitcode can run on any system with the JVM. Now you understand the JVM when we install the VS Code. JVM is used for Java execution. Now, one interesting thing, that is historical context belong that all. To appreciate this better, let's quickly look at the history. In 1940, the programmer wrote directly in machine code. Means when the first code is written, the programmer write the code in machine code, means in zeros and ones. Then came assembly language, which used short mnemonics like move, add, sub, easier but still close to hardware. Finally, we got high level language like C, Python, Java, CPP, designed for humans. So programming involves from machine friendly to human friendly, while compare evolved to bridge the gap. Means we come from machine friendly to here human friendly. Means the when first started with the machine code, it is very complicated to understand and complicated to execution also. And now we use the high level language like C, CPP, Java, Python, everything. Now, as I mentioned earlier, what is compiler and interpreter? What is the difference between it? Now, here is something important. A compiler translates the entire program into the machine code at once. Faster execution but takes time to compile. Compiler is take time to compile, but its execution is very fast. And interpreter translates line by line while running, slower but more flexible. Means what is the difference? Compiler is used when entire code is written and it can be executed at a time. And interpreter is used when we write when we write code line by line and execute line by line. So that is the difference between compiler and interpreter. Java uses both compiler and JVM. Now Java actually uses both approaches, but first the compiler, which is done by Java, convert code into the bitcode, then JVM interpreters that bitcode into the machine instruction. Now what is that? As I mentioned earlier also, what is the work of compiler? Compiler uses the command javac to convert the code into the bitcode, and the JVM interpreter interprets the bitcode into the machine instruction. That's why the Java is powerful. It balances the speed and the flexibility. Now, how the code execution flows. Now, suppose we write the code which is like class hello, public static void main, string arguments. Then we write the command for printing hello world, as we discussed in the previous video. Now, what is the steps to get execute? First, we save the file hello.java, then run the command javac hello.java. This creates the one bit code that is hello.class. Now, run java hello, then how it run? The JVM execute the bitcode first. Then the CPU runs the instruction and we see the output, that is hello world. That means firstly we have to save the hello.java, then javac hello.java, then it creates the one file java hello.class, and then we also last time we have to just give instruction java hello, then we get the desired output, that is hello world. As I see in the picture, just one correction is there. Here the spelling of javac is wrong. JAVAC is the right. So put attention on it. Now next, to extend our shape analogy a bit further, a recipe book. Now, recipe book is nothing but a programming library where multiple recipes are sorted. Now the kitchen is the operating system where everything runs. The stove in the kitchen is the CPU, the main engine, ingredient, which is the variable which holds the data we cook with. This analogy will help us as we move into the upcoming topic like variable in Java. Now, just understand everything is like a real time. If we have to just combine the real time analogy with the programming, it is very easy. Just I mentioned here, the recipe book is the libraries, kitchen is the operating system, then the stove is the CPU, and another ingredient is the variables. Now, we can understand everything by using the real-time analogy in this series. Now, as a summary, what we see in this video, with the help of the example of the shape and the recipe, the programming is the shape, the recipe is the code, compiler is the translator, and the CPU is the assistant. So when you run a Java program, it's just like a shape writing a recipe, a translator explaining it, and the assistant cooking it perfectly. This is how computer understand our code. That's it for day 4 of our programming series. Today we will learn how your Java code travels from the .java to the output. In the next video, which is day 5 of our series, we will talk about the variables in Java, which works like a container that holds your data just like a jar in the kitchen. Don't forget to like, subscribe and comment below with your fun analogy for how computer work. I had loved to read them.